All right, so we're going to take a look at a couple of examples of how to use a quadratic equation and find solutions and use our technology to make our lives easier. So our first one here, we have a long distance water ski jumper. His flight path is given here by this quadratic equation. How long does the water ski jumper hold his flight pose? So how long is he in the air? So when will he hit the water again? So we're going to start, we're going to graph this on our graphing calculator. We're going to go to y equals, and we'll just type it in as is. 5.0 plus 24.446, oh dear. 24.46 x minus 4.9 x squared. Hit graph. And we'll notice we don't see all of our graph. So we need to increase our y max because we would kind of like to see that the top of the graph. So we're going to go to our window settings under window. We're going to increase our y max to, we'll try 25. Hit graph. Oh, we need a little bit more. We'll make it 40. And we'll hit graph. All right, so we could find the maximum height of our water skier, but that's not what the question's asking. It's asking for how long did he hold his pose. So when did he return to the surface of the water? So we need this point right here. This is called a root or a zero or a solution for this quadratic equation. So to figure it out using our calculator, we're going to go second, trace, and we're looking for the zero, not the intersect, the zero. Hit enter, and we need our left bound to be on the left side of where it crosses the axes. And we need our right bound to be somewhere where it's on the right side of where it crosses. So I get an answer of t equals 5.19 seconds. So after 5.19 seconds, the water skier will make contact with the water. But over here it says the skier holds his flight pose until he's 4 meters above the water. So we need to find out where this graph is at 4. Because at 4 meters he comes out of his pose and gets into more of a landing friendly pose. So let's figure that out too. So we're going to graph y is equal to 4. Right, so then we're going to get an intersection point here where the water skier is going to come out of his pose. So this is where we would use something like intersect. We have two graphs and we want to find out where they run into each other. So we need to move our blinker on the first curve somewhat close to the point of intersection. Second curve, again, somewhere close to that point of intersection. Tell it to guess. And for a height of 4 meters, our time will be 5.03. So after 5.03 seconds, he will come out of his flying pose, and at 5.19 seconds, he will make contact with the water, hopefully skis first.